What's the biggest thing you can think of? And I mean something where you really have a feel for the size. For me, it's a football pitch. Because if I close my eyes, I can hear the crowd in the stadium. I can imagine how long it takes me to run from one side to the other. But as an astronomer, I often have to work with things that I can't imagine how big they are. They're just too big to fit into my head, to be honest. And the things I study are bigger than our planet. They're bigger than the sun. They're even bigger than the galaxy, the Milky Way. Which is frankly ridiculous, because our galaxy has hundreds of billions of stars in, and almost every astrophysical phenomenon you've ever heard of, whether it's black holes, exploding stars, planets, asteroids, comets, whatever, it's all in a galaxy. But I go one stage bigger. Because the things I study are called galaxy clusters, and they are the biggest things in the universe. Now, as the name suggests, galaxy clusters are made of thousands of galaxies, all held together by gravity. And in fact, this is one behind me here. And I know before I studied galaxy clusters, I'd look at a picture like this, and I thought each of these bright points was a star. But it's not. Each of those points is a galaxy with hundreds of millions of stars in. It's truly colossal. And this kind of picture makes it seem like a static system that's kind of just sitting there. But in fact, these galaxies are whizzing around faster than bullets. Although, since studying astronomy, I realised bullets are really slow. And it's not just that. This pink, blue, fuzzy stuff you can see, it's really hot gas. It's 100 million degrees. And it's so hot we can only see it in the X-ray. Now, for some people, all of that stuff is why they study these giants. But I don't really care about that. In fact, the only thing that gets me out of bed in the morning is the universe, as a whole. Because that's why I study physics, that's why I study astronomy. I want to know how it began, how it changes over time, what the fundamentals are. And these might just give us a clue to some of those questions. Because it turns out that the number of these objects, as a function of their mass in the sky, depends on how the universe has changed over time and just how much stuff is out there. So in theory, if we can count these in the sky and weigh them, then we can understand a little bit more about the universe. The hard part is the weighing bit, because we only can look at these objects. And there are lots of ideas about how we can do that, whether it's looking at the temperature of that hot gas, or looking at how light from behind the galaxy cluster bends as it passes by it. But we don't know how accurate those methods are. And that's where my PhD comes in, testing those different techniques to find out how well we can weigh these giants, and therefore get one step closer to using them to understand the universe.